Okay, so we see that this matrix has been built from the identity by first multiplying by this elementary matrix, then this one, this one, this one, and this one. Okay, so this matrix is the identity multiplied by this one, which we then multiply on the left by this one, multiply on the left by this one, and so forth. We'd have 1, 2, 3, 4, 5 matrices to the left of the identity. And it's very important to multiply them in the right order. This is the first matrix that's multiplied by the identity. It's got to be right next to the identity. If you were to write this matrix first in that string of 5, it wouldn't even be close to the identity. And remember that matrix multiplication is not commutative. You can't just write the matrices down in any order. They have to be written in the right order. So the right order is this one right next to this one, just to the left. And then this one is multiplying this one to the left, but this one is just this, so this would need to go to the left of this. And then this is just this, which is this times this, so this one goes to the left of all that. Each of these matrices would have to go to the left of the rest. So we would list the matrices, this one to the left, this one to the left, this one to the left, this one to the left. Now I'll put that into notation, but there's a little bit of a confusion about the notation because of the way we built this up. Okay? And I'll talk about that. Well, how would we then go from here back to here? Well, the inverse matrix is a matrix which, when we multiply by the original matrix, gives us the identity. Okay, so if we were to multiply this matrix on the left by this matrix, it would be the same as multiplying this matrix on the left by this product, which means that this matrix would go to the left of this matrix, but this matrix is the inverse of this matrix, so when we multiply them, we would get the identity here. And if we then multiply the identity by this matrix, this is what we get. Okay, so multiplying on the left, multiplying this matrix on the left by this has to give us this. And then multiplying this matrix, which I've written here, on the left by this matrix, well, this matrix multiplied on the left by this one is the same as this matrix multiplied on the left by this product. And this is the matrix that undoes this one, which when multiplied by this one gives us the identity. So multiply this on the left by this matrix, we're going to get this matrix. Now we've got this matrix, we're going to multiply it on the left by this matrix, which will make, be the same as multiplying this product on the left by that matrix, which would give us the identity, etc., etc. So by multiplying by these inverse matrices in turn, we get back to the identity. Now, how would we write that? Well, this matrix would have to be on the left of this one. And then this one would have to be on the left of what we get, which means we'd have this matrix to the left of this one, and then this to the left of that. So we'd have this matrix, then this matrix, then this matrix. Now multiplying on the left by this matrix, well, gives us another matrix on the left. So we would write down these matrices, this one next to this one to the left of that, 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 and that product would equal the identity. Okay, well, to see that a little more clearly, we're going to use some notation, and I'll explain the notation starting in the next clip, and we'll see where this leads us.